Welcome to Lecto. Today we are going to discuss SINOATRIAL node, which is the most important component of the heart. It is that component of the heart through which the signal generate and is spread to the whole heart. First of all, we will see the different aspects of the SINOATRIAL node. If we see the size of the SINOATRIAL node, you will see that the length of the SINOATRIAL node is the 15 millimeter. So 15 millimeter is the length of the sinoatrial node. Okay. And the width of the sinoatrial node is the 3 millimeter wide. And the thickness of the sinoatrial node is just 1 millimeter thick. So actually, sinoatrial node composed of different sinus nodal fibers. Whenever you see or you hear the word fiber, it's mean that I am going to discuss cell. Fiber is equal to the cell. Okay. So actually, sinoatrial node composed of different fibers or cell. Sinus nodal cells. Okay, lot of cells actually present in this sinoatrial node. That's very much important. If we discuss the location, actually where does sinoatrial node present in our heart? So we decide the location of the SA node according to two important components of the heart. First, we decide the location according to the superior vena cava, and second is the atrium. Okay, that's very much important. So if you see here is basically here is the right atrium and here is the right ventricle. Opposite to that, you will see here is the left atrium and here is the left ventricle. Okay. So first of all, we decide the location of the SA node according to the superior vena cava. So SA node is just below the superior vena cava and slightly lateral. So that's very much important. So below and lateral to the superior vena cava. That we decide the location according to the superior vena cava. So according to the atria, you will see the SA node is present posterolateral wall of the atrium. So that will be according to the atrium posterolateral wall of the atrium. You will see the SA node. So here is basically the location of the SA node. If we discuss the different properties, it is actually small in size. This node is actually small. Okay, that's very much important. This is actually small in size. Okay, and it is actually flat. It's not a round. It is actually a flat. Node is actually a flattened. That is again very much important property. And third main property, it is actually ellipsoid shape strip having different cells or fibers. So it is actually a ellipsoid shape, okay, and contains different fibers or cells. Okay. So actually the cell fiber that is actually present in the SA node is basically 3 to 5 micrometer in diameter. So if you see, the cell that is actually present in the SA node will be 3 to 5 micrometer in diameter. But if we do comparison with the atrium, so the atrium fibers or the cell is actually 10 to 15 micrometer. It shows that the cell that is actually present in the SA node is how much smaller as compared to the cells of the atrium. So this is actually the general properties of the SA node. In our heart, you will see the three most important system. First one is the excitatory system. First is the excitatory system. Excitatory respiratory system. Okay. Second system in our heart is the conductive system. Conductive system. And the third system that is very much important is the contractile. Contractile system. Okay. All these, the rhythm of all these systems should be proper. Improper rhythm of all these systems will create problem. Okay. First, it will look like similar to an example. If you see here, if someone wants to rotate the fan, first component is the switch. First, someone has to switch on the switch. After that, the current flows through the wires. This is the second thing, and after that the fan start rotating. So similarly, the switch is for the excitation. Switch represent the excitation. Second is the conduction. Current flows through the wire and that shows the conduction. And last is the rotation, that is actually the mechanical work. Similar to that, first one is the excitation and that will happen in the SI node. After that, the signal travels through the different fibers and that process is actually the conduction. And after that, the heart muscles will start contracting and do some work similar to the fan. So here are basically the three different processes that actually happens in the heart, and you will see the heart pumps effectively only if the rhythm of all these systems will be proper. Okay, so see, if you see here that first is the SI node. Here is the SI node. Okay, from the SI node signal starts producing, and after that signal travel to the AV node. AV node, that is atrioventricular node. This is the second node, atrioventricular node. Okay, along with that signal travel to the right atrium along with the left atrium as well through the bundles, and that bundles will be the Bachmann's bundle. Bundle travel to the left side, left atrium through the Bachmann's bundle, while the signal present in the right atrium as it is. After that, the signal from the AV atrioventricular node goes into the between the septum, that is actually through the fibers, and that fibers is the bundle of His, or you can say atrioventricular bundle. So signal travel from the bundle of His, or you can say atrioventricular bundle. That's very much important. Okay, and it will divide into two branch, left branch and the right branch. So if you see here, they will divide into the left branch and the right branch. Okay, after that the signal goes downward and supplies to the muscles of the ventricle through the Purkinje fibers. Okay, you see that the most important thing which you have to remember, the left bundle supplies lot of fibers to the left ventricle. Why? Because left ventricle has to contract stronger as compared to the right ventricle. So the left ventricle do more work comparison with the right ventricle. So these are basically the different system. First one is the excitation happens in the SI node. Second, you will see the conductive system through the different fibers. That will you will see the depolarization, repolarization that happens in these fibers. And after that, you will see the muscles of the atria and the ventricle start contracts and the pumps and goes outside the heart, or you can say cardiac outputs you will see. Okay, that is actually the three system. If we see what happens actually in the SI node, so that's very much important. If we see, this is actually the sinus sinus nodal fibers, or you can say cell. What actually happens in the cells of the SI node? So first of all, the cell will be present in the negative state. Potential inside the cell will be negative compared to the outside. Okay. So in that situation, what will happen? So most important channel, that is actually the sodium channel, or specifically funny sodium channel. Funny sodium channels. Okay. Sodium that is actually present outside in the extracellular space will start moving inside the cell. Okay, and after that, what will happen? The negative will remain two sign. Okay, so if we do comparison this with the graph, so on the x-axis we take the time in the second, on the y-axis we take the volt, that is in millimeter. So after that, first of all, when the sodium enters into the cell, at the starting point, the cell is actually present in the negative potential, and that is the minus 60 millivolt. Okay, when this funny sodium channel open and the sodium start moving into the cell, the potential will become less negative. It's mean it will goes towards the positivity. So it's mean that after that opening of the sodium channel, the potential will goes towards the minus 55 millivolt. That's very much important. After that, you will see the sodium funny channels become inactivated, and you will see the opening of the T-type calcium channel. T-type calcium channel. Okay. So in that situation, what will happen? Calcium starts moving inward. Calcium starts moving inward, and calcium starts accumulate inside the cell. Okay. So actually, you see the two negative sign and one positive sign present outside. And in that situation, again, one positive negative sign will also remove. Why? Because the positivity inside the cell starts increasing. Okay, in that situation, the graph will start moving upward, and it will goes towards the threshold value, that is minus 40 millivolt. That is actually the threshold value. That's very much important. Minus 40 millivolt. After that, you will see the opening of the most important another type of the calcium channel, and that is L-type calcium channel. So after that, you will see the opening of the L-type calcium channel. So they are actually slow. They will slowly open and slowly close compared to the T-type. So SI node is the only cell having both T-type calcium channel and L-type calcium channel as compared to the muscle fibers of the heart. So in that situation, the calcium that is actually present outside starts moving inward. Okay, then what will happen? So in that situation, the remaining negative sign will convert into positive, and the outer will become the negative. Now the sign has been changed. Inside become positive and outside become negative. So in that situation, the graph will goes towards the positivity, and that is plus 40 millivolt. That's very much important. Negativity at the starting, you will see the lot of negativity inside the cell. After that, when the T-type calcium open, negativity will become less. And after the opening of the L-type, negativity completely vanished, and the positivity starts inside the cell compared to the outside. Okay. And after that, you will see the openings of the K potassium channels. Potassium channels. Okay, that's very much important. In the potassium channels, the potassium that are actually present inside the cell starts moving outward. So in that situation, what will happen? So negativity again starts increasing inside the cell because the positive charge start moving outward. So it's mean the negativity create will be inside the cell. So it's mean that the potential will starts reversing. That is actually repolarization. This whole process is actually the depolarization in which the positive will convert into negative will convert into the positive, but in the repolarization it will again convert into negative. So in that situation the potassium starts moving outside the cell and it will move toward the minus 40. That again will be minus. And after that the channel will remain open and the potassium move outward, outward, outward until you will see it will goes towards again the starting point, and that is minus 60. And that's from the thrust hole at the minus 60, that is hyperpolarization due to the opening of the potassium channel will open for a long period. So ultimately potassium will goes outward. So ultimately you will see the negativity starts creating inside as compared to outside. So this is actually first step is the depolarization, and again you will see the repolarization. So this is all about the SI node. If you still have any question, you may ask in the comment section. Thank you so much.